Have you ever wondered why animals from the same species can look so different? Throughout the evolution of species, natural selection has led to the development of dimorphisms within species. A dimorphism is defined as a difference in form between members including color and body size. Most dimorphisms seen in nature are sexual dimorphisms between males and females, where the presence or absence of specific structures can be deterministic of courtship, displays, and contests.
And I've noticed that elephants can look really different sometimes.
You know, I've noticed that too, and that's because they also have dimorphic traits.
Really? Like what?
They have tusk, musk, and body size.
Oh, wow. Okay, can you explain those?
Yeah, so tusk is either the presence or absence of them. Musk is an intense state of sexual arousal that allows a male to be more aggressive. And body size, you just compare their sizes.
Wow, okay. Did you know that these dimorphic traits are really important in the male's ability to win his male-to-male competition? Also, it's important in his ability to find a female to reproduce with. Do you mind explaining the types of interactions in a male-to-male competition?
Yeah, absolutely. So in a male-to-male interaction between elephants, either non-tactile dominant, tactile dominant, or subdominant behavior may be displayed.
So what does that mean?
An example of non-tactile dominant behavior is a circular head shake. This is where the elephant shakes his head vigorously in a plane perpendicular to the ground. An example of tactile dominant behavior is fencing with tusks. This is where a pair of tusked males clash their tusks without any other body contact between them. An example of subdominant behavior is freezing. This is where the elephant stands still. We found out that two researchers from the Indian Institute of Science, Chalia and Sukumar, were interested in which of the three dimorphic traits in male elephants was most important in winning competitions.
Previous research had been done on musk status and body size in determining dominance in elephants independently, but the correlation between all three traits had not been done.
During the course of their observations, they defined competitive male-to-male interactions between a pair of males when at least one of the males is aware of the other's presence and one or more of the behaviors demonstrated previously was observed.
Sexually active males from ages 15 to 55 may engage in combative interactions to establish dominance. The loser was defined as the male elephant at the end of the interaction displaying subdominant behavior, and his opponent as the winner.
So Shelby, what do they do to analyze their results?
Thanks for asking. So a statistical analysis was performed to predict the probability of the male winning his competition based on body size, musk status, and tusk status. And here are the results.
54 of the 82 individuals that had a tusk advantage won. And within those wins, 36 of the individuals had a musk advantage and the majority had a body size advantage. Of the losses, most of them had a musk disadvantage and a body size disadvantage as well.
From the second part of the graph, we can see that the individuals have an even musk status, and from this you can see that the individuals with a smaller difference in their body size with the tusk advantage showed a greater number of wins over losses, whereas the individuals that had a great difference in body size, also with the tusk advantage, did not show a huge difference here. So from this we can see that body size is really the determining factor when the musk status is equal.
This image shows that there's a stronger correlation and wider gap for a musk advantage in winning a male-to-male competition versus a lesser correlation for a tusk advantage in a male-to-male competition.
So what does that mean? Selection for musk, tusk, and body size has occurred within elephant populations in response to male-to-male competition. Wins in competitions within species play a major role in their future of the evolution of that species. The elephant's dimorphic traits provide us with the opportunity to see where these species may be headed in future generations where musk rather than tusk is most important.
Even though the elephant populations we're focused on here today, the same evolutionary concepts can be applied to other species with dimorphic traits.
Well, you can tell everybody, yeah, you can tell everybody, go ahead and tell everybody, I'm the man, I'm the man, I'm the man. Yes I am, yes I am, yes I am.